The last test that we're going to learn about in Chapter 5 is going to be the root test. This test is going to be extremely similar to a lot of what you did with the ratio test. The difference here, however, instead of taking the absolute value of n plus 1 over n, here you're going to take the nth root of the whole thing. Okay, so let's just go over this. Consider this series. We've got an, although we have some a to the k's here. Don't worry about what letter they use for that. It means an, or convert it to whatever you need to. Again, this is rho. There's a symbol for rho. It's the limit, but this limit is the nth roots of the absolute value of our series. Of the absolute value, yeah. So you need the absolute value because you can't take the nth root, if n is even anyway, can't take the nth root of an odd number. Can't. So just assume that we're taking the absolute value of it. So your conclusions, if this turns out, when you take this limit, if this rho turns out to be greater than or equal to 0, which it's got to be, again, we're not going to be dealing with negative values, so that shouldn't be an issue. But this strictly less than 1, we get convergence. And not only convergence, but absolute convergence. That's the same as we had with the ratio test. Also the same, number 2, if we get a rho of greater than 1, again, infinity counts as greater than 1, then our series diverges. However, if we get rho equal to 1, it does not provide information. No information, not information. All right, so let's take a look at this. They want us to use the root test specified to determine whether or not our series of a to the n converges, where a to the n is as follows. They give us a to the k, so we're just treat it as k. No problem. So we're going to let rho equal the limit as n approaches, k, excuse me. We'll use k. K approaches infinity of the kth roots of the absolute value of k minus 1 over 2k plus 3, quantity all to the k. All right, so what happens here? This equals limit as k approaches infinity of this k minus 1 over 2k plus 3, quantity to the k over k, which is just 1, so we just get our original back. So this equals the limit as k approaches infinity of k minus 1 over 2k plus 3. We can use L'Hopital. L'Hopital gives us limit of k approaches infinity of 1 over 2, which is 1/2. This is less than 1, so our series converges absolutely. And then again, that's by the root test. Now let's take a look at number 329 here. So our limit, our rho, is the limit as, again, a k. And we're going to take the kth roots, the absolute value of this. Which again, we get limit k approaches infinity. This is again going to be the k over k, so we get 2k squared minus 1 over k squared plus 3. We can use L'Hopital's. We can also determine, the highest order here. Both of these are k squared. There's nothing other than that. This is just a polynomial. You can take a basic limit of this without using L'Hopital twice. So this equals 2 over 1, which is 2. Note 2 is greater than 1. And this means that our series diverges. Again, root test. That would be number 2 on this.